Basic properties of logarithms. The goals for this lesson is to understand the basic properties of logarithms and use the different rules for logarithms, namely the product rule, quotient rule, and power rule for logarithms. Now recall that logarithmic and exponential functions undo each other. That means they are actually inverses of each other. This means that logarithms have similar properties to exponents. Some important properties of logarithms are given here. First, the following properties are easy to prove. The log of 1 base b is equal to 0. So just by remembering the definition of logarithm, this one means you think of an exponent for b to get number 1. So where would you raise b to get 1? You would raise it to 0 because b to the 0 is equal to 1. And also log of b base b. So to solve this, you are to think of an exponent where you would raise b to get b. To do that, you just raise it to 1 because b to the 1 is equal to b. For example, log of 1 base 5 is equal to 0 since b to the 5 to the 0 is equal to 1. And also log of 5 base 5 is equal to 1 since 5 to the first power is equal to 5. Next, we have the inverse property, namely log of b to the x base b is just equal to x, and b to the log of x base b is equal to x whenever x is greater than 0. Both of these properties can be proven just by using the definition of logarithm. So the basic definition of logarithm is to just think of the base and think of where to raise that base to get the number x. So for instance, if you are given the function y is equal to log of x base b, this is the definition. The definition of logarithm is to think of where to raise this number here to get x. So equivalently, this is just equal to b to the y equal to x. So the base is b, the exponent is y, and the number is x. So for instance here, using this definition, you have base b here. So with that, you have base b, and then this b here will be raised to the number here. This is the exponent, so b to the x, and that is equal to this number here, b to the x, which is actually true. B to the x is just equal to b to the x. So similarly, this one here, if this is equal to y, like in the definition, y is equal to log of x base b, we know from here that this is equivalent to this, b to the y is equal to x. So if this is y, then we will just have, from this expression, we will just have b to the y equal to x, which is actually what we have here. So this statement is also true for all x greater than 0. Now to illustrate that, we can actually look at some examples. For instance, let us evaluate log of 100. So to evaluate log of 100, we can just rewrite the logarithm as 100 will be written as 10 squared. And then we have log of 10 squared base 10. Then apply this property here. The answer is 2. And to evaluate e to the ln of 7, we would think of ln as log of e. So therefore, we can rewrite this as e to the log e, base e, log base e of 7. And then apply this property here. We know that this expression here just cancels and you just extract this. So the answer here is 7. E log of 7 base e is equal to 7. Finally, we have the one-to-one property. For the one-to-one property, this states that if you have log of m base b equal to log of n base b, this statement here is true if and only if m is equal to n. So with this property, whenever you see this expression here, if log of m base b is equal to log of n base b, you would then immediately say that m is just equal to n. And similarly, if you have two expressions that are equal, you can take the logarithm of both sides without changing the equality symbol. So with this property, we can use that to solve this given expression here. Log of 3x base 3 is equal to log of 2x plus 5 base 3. Notice that both of these expressions have the same basis. So that's the most important thing that you have to remember. You have logarithm of the same base on both sides of the equality. And then if that happens, you can essentially like cancel this expression here, log base 3. And then you have 3x equal to 2x plus 5. So this property is what we call this property the one-to-one property. And then we are just going to solve this equation here. So it boils down to solving this equation. You can transpose 2x on this side. So you have 3x minus 2x, that is equal to x. And then just bring this down, 5. So x is equal to 5. Now let's answer the following questions using the basic properties of logarithm. So for number 1, we have ln e to the first power. So to answer that, we are just going to use the inverse property of logarithms, namely log of b to the x base b is equal to x. So in order to apply that, we are going to rewrite ln e to the 1 as log base 3 of e to the 1. So since we know ln, whenever we see ln, that's the natural logarithm, that means we have logarithm base e. And then after we've written it in this form, we know that if we have this expression here, this is just equal to the exponent here. So that is equal to 1. Using the properties or inverse property of logarithm, namely log of b to the x base b is equal to x. Next, for number 2, we want to evaluate log of 5 to the 6 base 5. In here, we can still use the inverse property of logarithm. Same thing, log of b to the x base b is equal to x. And so therefore, whenever we have this expression here, this is just equal to the exponent here. And therefore, this log of 5 to the 6 base 5 is just equal to x. Now, lastly, we want to evaluate log of 1 base 6. So to evaluate this, we are just going to use the definition for logarithm. We will just ask ourselves, where would we raise 6 to get 1? Or to what power should we raise 6 in order to get 1? So remember that 6 to the 0 is equal to 1. Any number except 0, when raised to 0, is equal to 1. So therefore, this log of 1 base 6 is just equal to 0. Now let's discuss the product rule for logarithms. Recall that we use the product rule of logarithms to combine the product of exponents by adding. So recall that if we have x to the a times x to the b, to combine these two, we just copy the base x and then add their exponents. Now we also have a similar property for logarithms. We call that the product rule of logarithms, which says that the logarithm of a product is equal to the sum of logarithms. Now, and because logarithms are exponents, if you recall the logarithmic function, the output for that is just exponent. So logarithms are exponents. So because of that, we multiply like bases and then we can add exponents. Therefore, the product rule for logarithms can be used to simplify logarithm of a product by rewriting it as a sum of individual logarithms. The logarithm, the product rule for logarithms is given by this formula. The logarithm of mn base b is just equal to the sum of logarithms, the logarithm of m base b plus the logarithm of n base b. And this is true for all b greater than 0. Now let us apply the product rule for logarithms to expand the expression here, log of 4 times x plus 1 base 6. Now to solve this, we begin by factoring this expression here completely. So therefore, we would write 4 as a product of primes. So we know that 4 is equal to 2 times 2. Now that we're able to completely factor this expression here, we can then use the property or the rule for the product rule for logarithm, namely log of mn, the logarithm of the product, is just equal to the sum of logarithm. This is equal to log of m base b plus log of n base b. So the logarithm of the product here is equal to the sum of the logarithms. So this is equal to log of 2 base 6, log of 2 base 6, plus log of 2 base 6, log of 2 base 6, and log of this expression x plus 1 base 6. These two terms here are the same, so we can combine them. Log of 2 base 6 plus log of 2 base 6 is equal to 2 log of 2 base 6. And then just copy this, so plus log of x plus 1 base 6. Therefore, the expanded form of log of 4 times x plus 1 is equal to 2 log 2 base 6 plus log of x plus 1 base 6. Next, we want to expand logarithm of 9x base 8. In order to do that, we're going to use the product rule for logarithms since we have a product here. But before we can do that, we will first write this in factored form before we can apply the product rule for logarithms. Now note that 9 can be written as 3 times 3. So therefore, we write 9x as 3 times 3 times x. So therefore, log of 9x base 8 is equal to log of 3 times 3 times x base 8. Then after that, we can use the product rule for logarithms, namely the logarithm of the product is equal to the sum of logarithms. Therefore, we can write this as log of 3 base 8, log of 3 base 8, plus log of 3 base 8, log of 3 base 8. And then log of x base 8. Again, the logarithm of the product is equal to the sum of logarithms. Now, these two here are the same, so we can combine them as 2 log of 3 base 8. And then plus, copy the expression here, log of x base 8. Therefore, the expanded form of logarithm of 9x base 8 is equal to log of 3 base 8 times 2 plus log of x base 8. For quotient rule for logarithms, we recall the quotient rule of exponents. So if you recall, x to the a over x to the b is equal to x to the a minus b. So if we are dividing exponential expressions with the same base, we just copy the base, the common base, and subtract the exponents. Now we can use that same principle for logarithms. The quotient rule for logarithms says that the logarithm of a quotient is equal to the difference of the logarithms. So that is log of m over n base b is equal to log of m base b minus log of n base b. Again, the logarithm of a quotient is equal to the difference of logarithms. Now let us use the quotient rule for logarithms to expand the given expression here. So we want to expand log of 14x times x minus 2 all over 2x plus 3 times 4 minus x base 6. So to do this, we first note that the quotient here is already factored in its lowest terms. So we can now directly apply the quotient rule. Remember, the quotient or the logarithm of the quotient, so logarithm of m over n base b is equal to the difference of logarithms, log of m base b minus log of n base b. That's the rule. So therefore, the logarithm of 14x times x minus 2 divided by 2x plus 3 times 4 minus x. So this is the quotient. You think of this as your m, and this is your n. So the logarithm base 6 of this m over n is just equal to the logarithm base 6 of your m expression, that is 14x times x minus 2, minus the logarithm of your n expression. Now notice that we can apply the product rule for the expressions here. But before we do that, we have to completely factor this expression first, since this one is not completely factored. We can still write this as a product of 2 and 7. So we need to write even the numbers as prime or product of prime factors. Now rewriting 14 as 2 times 7, then applying the product rule, we have log of 2 base 6 plus log of 7 base 6 plus log of x base 6 and then log of x minus 2 base 6. Here we have log of 2x plus 3 base 6 and log of 4x base 6. Now, to end this one, you just have to remove the parentheses here by distributing this negative sign here to each term inside the parentheses. So therefore, the answer here, this expression here becomes negative log of 2x plus 3 base 6, and this one is negative of 4 minus x base 6. Note also that there are exceptions to consider in this example. First, because denominators must never be 0, this expression is not defined for x equals negative 3/2 and x is equal to 4. And also, since the argument, that is the expression inside this logarithm here, must always be positive, so therefore we make sure that each of the argument here is positive for values of x. So that means that we have to make sure that x in this case must be greater than 0. In this case, x must be greater than 2. And for this to be true, x must be greater than -3/2. And this one, for this to be true, x must be less than 4. Next, we shall apply the quotient rule for logarithms to expand this given expression here. To do that, we will think of this as our numerator. This will be the expression m, and the denominator 8 will be the expression n. And recall that the logarithm of the quotient, logarithm of m over n, is equal to the logarithm of m minus the logarithm of n. Or you could also think of this as different bases, or base b. So applying this property here, we can rewrite this expression as log of y over x minus log of 8 base 5. And then we can also apply again the loss of, or the quotient rule for this expression here. So applying quotient rule for logarithm of y over x base 5, we can write that as log of y base 5 minus log of x base 5 minus log of 8 base 5. So now that we've explored the product rule and the quotient rule, we're now going to look at the third rule for logarithms, also known as the power rule for logarithms. This would help us take the logarithm of a power. So such as, for instance, we have logarithm of x squared base b. Note that we can write or use the product rule here by writing x squared as x times x. And so therefore, we can just use the product rule from here. We can write this as log of x base b plus log of x base b, and then combining those two, you get 2 log of x base b. Now, if you notice here, the logarithm of this expression, logarithm of x squared base b, note that in the final answer, if you compare this with a given expression, this is the same as taking this power here and putting it as a coefficient and then copying this expression here. So the rule that is being applied here is called the power rule for logarithms, which says that the logarithm of a product is equal to the exponent times the logarithm of the base. Keep in mind that although the input to a logarithm may not be written as a power, we may be able to change it to a power. For example, if we have 100, 100 may be written as 10 squared. So this is the exponential form of 100. And square root of 3 may also be written as 3 to the 1/2. 1 over e may be written as e to the -1. Now, the power rule for logarithms can be used to simplify the logarithm of a power by rewriting as a product of the exponent times the logarithm of the base. So again, the logarithm of m to the n base b is equal to the exponent times the logarithm of the base m base b. For example, let us expand logarithm of x to the 4th base 3 using the power rule. As you recall, the logarithm of a power is equal to the product of the exponent times the logarithm of the base. So with this, we can just take the exponent, in this case, it is equal to 4, and then multiply that to the logarithm of the base here. Another example, expand logarithm of the cube root of x. So to be able to use the power rule to expand this, we will have to rewrite cube root of x as x to the 1/3. So x to the 1/3. And then we can apply the product rule to expand. The product rule states that the logarithm of x to the 1/3 is just equal to the product of the exponent times the logarithm of the base. So it's 1/3 times logarithm of x.